Hi, thanks for joining us again for this video in Chapter 2 of our great organic chemistry class. In this chapter, we just want to kind of introduce you to the idea of nomenclature of the most simple type of molecules, alkane series. And nomenclature is not something that like we want to necessarily super emphasize in this class, but we do need to be familiar with it to some extent. The biggest emphasis is going to be understanding the reactions, and so the biggest emphasis throughout the year it's going to be how can you predict the outcome of a chemical reaction, and can you explain how that reaction happens, aka the mechanism, and using all of that concept, can you propose a way to synthesize or make any organic molecule we throw at you? Those are the main goals, but along the way we do kind of need to be able to communicate with one another, and so for that reason nomenclature or naming and drawing of molecules, that's going to be necessary. And for that reason, throughout the semester, we're going to have a few nomenclature or drawing and naming quizzes during class, in class. And that it's something, again, like we don't necessarily want to have to emphasize, but it's kind of a necessary material. So we'll do that. And the main thing that we might cover during class time for these things is, of course, it's going to be practice naming or drawing structures based on names. And alkanes, remember, is not very acidic, and it's kind of the very nonpolar, most boring functional group. And technically you could say alkane per se does not have any functional group. That's probably a better way to think about it. All these functional groups are placed on alkanes. That's kind of a better way to think about it. Alkane is just kind of this inert, simple, boring backbone, okay, of organic molecules. But how do we name these things? Well, let's think about this particular example. This guy, here's the IUPAC, that stands for International Union of Pure and Applied Chemistry. If you ever thought that there might be a secret society of people that sort of make organic chemistry hard for you or something, there actually is such a group, and that's the IUPAC. I just want you to know I'm not invited to be a member or anything like that, or nor do I want to be. But if you hate these IUPAC nomenclature system, please don't blame me. That's just what they decided, and that became the international standard. So what are the procedures for naming things? First, you want to find the longest chain. So in this case, this is 1, 2, 3, 4, 5 carbons is the longest chain in this molecule. So that's called, when you have 5 carbons, 5 in Greek is of course penta, and so this is called pentane when you have 5 carbon long alkane. And that should not be too surprising, because every functional group name ends with or keeps the suffix, I should say. So all alkane molecules have this ending "ane." Likewise, all alkenes have this ending "ene," or all alcohols have this ending "ol," something "ol," or stuff like that. Anyway, so 5 carbon alkane would be pentane or pentane. Okay, and then the next thing we should do is name all the substituents. First, I guess I should mark that we named this main chain, which has 1, 2, 3, 4, 5 carbons in it. And there is indeed a substituent right here, and that's the branching, is another way to think about it. And this is a single carbon, so that would be called a methyl group. Okay. Anything else but hydrogen that's attached to the main chain is considered a substituent. And then we have to name the longest chains starting number the longest chain starting at either end, but we want to pick the end that basically shortens or lowers the numbering. Okay, so that means here I first numbered it starting at this end, 1, 2, 3, 4, 5, but that means the substituent position number would be number 4, and that's not ideal. That's not the lowest we could go. Rather, it would be better to number from the other side, 1, 2, 3, 4, 5. Then we could say that the methyl substituent is on the second carbon. So that's what that means. And then substituent, put the substituent names in alphabetical order. Like if there's a methyl and ethyl group together in the same molecule, ethyl comes first because E comes first in alphabet. And then number by prefix, what that means is like if you have 2 methyl groups in a single molecule, you say dimethyl. If you have 3 trimethyl, if you have 4 tetramethyl, and so forth. And then we indicate the location of the functional group, or sorry, the substituent, by Arabic numeral. Those are the normal, like 1, 2, 3, 4, 5, that kind of numbers. So without further ado, what would be the name of this molecule? This would be, the core part of the name is going to be pentane, like we already established. The substituent, there's only one of them, that's the methyl group. And it's on the second, there's only one of those, we don't need to say mono. If there's 2 of them, we have to say dimethyl. The location is 2, so we're going to say this is a 2-methyl. And I want you to notice this number 2 doesn't indicate that there's 2 methyl groups. That just means the methyl group is on the 2 position, 2-methyl pentane. And notice there's no space between L and P there. It's a one word, okay, 2-methyl pentane. And how do we know that that's a methyl group? How do we know that's a pentane? We do kind of need to know some basic names here for the main chain and the substituents. Right, and for alkanes, you probably already know that this is methane. That's the smallest alkane. The second smallest would be ethane, and I trust you'll be able to draw the low structure of that. The next one up would be this molecule, which would be propane. Now, starting at propane, we actually could technically start drawing the line structures, right? Like this. And this would be butane. Ethane technically could be drawn as that, but that's not very helpful because it's hard to tell if that's a structure or just a line. And methane would be worse because it would just be a dot. So we usually only start doing the line drawing with propane. And then here's butane. Of course, this, oops, 2, 3, 4, 5. This would be pentane, as we already covered. So methane up to butane, it's kind of difficult because those don't follow any Greek word, but pentane and below or above, they all follow the Greek numerical system. Like this would be 6 carbons, so you may have guessed that this might be hexane. 7 would be hepta. 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, heptane. Might be helpful for you to know, like September is actually coming from the word hept, and it was supposed to be the 7th month, but then I think they added June and July in the middle, so it became the 9th month. But anyway, and then 1, 2, 3, 4, 5, 6, 7, 8. 8 would be octane or octane. And for that matter, the month October was supposed to be the 8th month, but again, they added June and July or something in the middle, so like that messed it up. It became the 10th month. And then nonane is the 9-carbon alkane. And November, again, was technically supposed to be the 9th month. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be decane. And you might guess what I might say, that the month December was supposed to be the 10th month, but then it became the 12th. If you have a C11 compound, which would be C11H24, that would be undecane, as in like uno or 1, okay? And you might notice that all alkanes have this general formula, CnH2n plus 2, if you count the number of hydrogens, okay? Like for instance, propane would be C3H8, that would be CmB3, so 2 times 3 plus 2 is 8 hydrogens, and so forth. So those are the names of the main chains. What about the substituents? Well, those substituent names those are based on those main chain names. Like this would be when CH3 group is attached to something, just 1 carbon, that would be called a methyl group. Notice the ending is just replacing with YL, il. When the substituent is an ethane group, so CH2, CH3 is attached to something, that would be ethyl group. When it's propyl group attached to something, that would be 3 carbons after propane. 2, 3, 4. So this, hopefully you could guess, this would be a butyl group, but the butyl group could be drawn in different ways. Like this could be written as N-butyl, actually, as a normal butyl, because here's the not so normal butyl. This would be called T-butyl group, or tert-butyl. It's short for tert or tertiary butyl. And then another, I forgot to mention, for propyl group, you could have this. This is isopropyl. Those are some other examples of variations of butyl or propyl group you might see. So this could be called N-propyl as well. Notice for ethyl and methyl, you can't draw it any other way or attach it any other way. In some of the other substituents, the easiest functional groups I want you to be aware of might be halogens. So there would be, if fluorine is attached to something, that's what this sort of squiggly line means. This means fluorine is attached to an alkane through a bond. So there's the rest of it here. That's kind of what these squiggly lines mean. This would be called the fluoro group after fluorine. Notice the spelling. And this would be chlorine or chloro group. And at this point, you could probably guess what this would be called. This would be bromo group. And this would be iodo group. Okay, so those are the halogen substituents I want you to be already aware of. So with that, how do you either name or draw some more complex alkanes or halalkanes? So let's practice that, and we'll do way more practice during class time. But let's think about this particular example to put it all all these IUPAC nomenclature rules into practice. So remember the first step, find the longest chain and name it. You might be tempted to say this is the longest chain, but the longest chain is not 1, 2, 3, 4, 5, 6, 7, 8 octane, but this is the longest chain, 1, 2, 3, 4, 5, 6, 7, 8, 9 nonane. So the longest chain should be right here. Nonane, okay. So, and then we're going to, maybe I'll say, that's step number 1. Step number 2, name all the substituents. So there's this substituent, and this substituent. I want you to notice both of these are methyl groups. 1 carbon, this is an ethyl group. Okay. And then we need to number the main chain either, so we have the option either starting with this end or this end, but we pick the end that would minimize the location numbers. So hopefully it makes sense to you that we should start numbering from this end. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then substituents at the carbon number 4 and 5. If we did it the other way, it would have been carbon number 1, 2, 3, 4, 5, and 6. So this is the better way. Okay, so how do you put all these together? I want you to notice the ending should be nonane, and then we rearrange the substituent names in alphabetical order. But when you do that, the numerical prefix doesn't count in the alphabetical order. What we mean by that is here we have 2 methyl groups, so that's should be called dimethyl. It's 2 methyl groups, but we're gonna pay attention to the letter M in terms of alphabetical order and E. So ethyl comes before dimethyl in alphabetical order. Hope that makes sense. And then the ethyl group is at the carbon number 4 position, so 4-ethyl. And then there's dimethyl, but those 2 methyl groups are at carbon number 4 and carbon number 5. You have to indicate where the 2 methyl groups are, so it's 4,5 dimethyl nonane. Okay. And again, we'll do a lot more practice than this, but let's see if we could at this time draw a structure based on a name. And I usually find drawing is easier than naming, at least for me. But part of the reason is you can start drawing something pretty immediately, even if you have to figure out some of this detail over here, or the complex part, what's going on. But the stem of the name, the core of the name is decane, which means I should be able to just immediately draw a decane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a decane. And we have a total of 2 substituents here and 3rd substituent here. This is like 1 substituent, and that's why it's in a parentheses, because this single substituent has in it 1, 2 substituents in it. So this propyl substituent has 2 substituents on it, so that's why it's got that complex parentheses bit. Okay. And when you have such complex substituent, what happens is you number. The numbering within that parentheses is going to be different, numbering scheme. You number starting at the attachment to the main chain. When you have such complex substituents. Okay, so this just means from the fluoro group is on the same carbon that's attached to the main chain, and the methyl group is on the second carbon away from the attachment. That's what that means. Okay, all right, let's just put all this together. So the first part, 2,2-dibromo, is relatively easy, but let's number these carbons first, perhaps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 2,2-dibromo just means there's a bromo group on the second carbon, and yet a second bromine on that second carbon. And then the complex propyl substituent is on carbon number 5, right? So we have the propyl group coming off of it, 1, 2, 3. And within this propyl group, here's the attachment carbon. So this would be carbon number 1, 2, 3 within that substituent. Okay, so there's a fluoro group on carbon number 1 of that substituent, propyl, and then there's a methyl group on carbon number 2. So there you go. So that's the structure there. And we'll do more practice in class, but let me know if you have questions.